The objective of this tutorial is to do an application where through it we can use definite integration to find areas under curves. In the previous tutorial we saw the formula. It is integral y dx starting from a to b. When we want to find the area between the curve, the x-axis and the lines x equals a and x equals b, where y is f of x, which is the equation of the curve. We will solve this example. Find the area of the region R bounded by the curve with the equation y equals 4 minus x times x plus 2 and the positive x and y axes. Here the information is not very clear. We don't know the line x equals a and x equals b. We need to deduce them from the sketch that we will do for the curve. If we expand this equation, then it will be a quadratic function. Ax squared plus bx plus c, where a, the coefficient of the x squared, is negative. Remember that when the quadratic function is like this, then it resembles the parabola, which is open downward since the a is negative. Before writing the formula, we need to sketch this curve. We need particular points in order to do the sketch. Y equals to 0. That means this function is equal to 0. 4 minus x times x plus 2 equals 0. 4 minus x equals to 0, or x plus 2 equals to 0. So the x is either 4 or minus 2. These are the first 2 points that we found in order to sketch the parabola. Now we will set x equals to 0 and we will substitute each x. That means y equals 4 minus 0 into 0 plus 2. 4 into 2, y equals to 8. So the points that we will sketch are 4, 0, we write the x then the y, minus 2, 0, and finally 0, 8. Here we have the x-axis and the y-axis. Now we will assign the points. We have 4 and 0. 1, 2, 3, 4. This is 4. This point is 4, 0. Now for minus 2 and 0. And finally 0 and 8. Now we connect these points. This is the parabola. Okay, now we need to look at region R. The region R is bounded by the curve. This is the curve, and the positive x-axis, if you look at the coordinates, this is the positive x-axis, it is here, and the y-axis, so this is the y-axis here. Where is the region between the curve, the x-axis, and the y-axis? This is the region. So this is R. We need to find the values of the x-axis. The value for x here is 0. And here the value of x is 4. Now we need to express the area. Area of the region R is integral y dx, where the values of x starts at 0 and ends at 4. So, integral from 0 to 4 for the function 4 minus x times x plus 2 dx. In order to integrate, first we need to expand this function. 4 minus x into x plus 2. We will cut the first term. 4 multiplied by x plus 2 minus x multiplied by x plus 2. Now we expand. 4x plus 8 minus x squared minus 2x. Now we organize by the decreasing degree of x. Minus x squared plus 4 minus 2 plus 2x plus 8. This is the function. We write it above. We do the integral for function minus x squared plus 2x plus 8 dx. Now we put the square bracket from 0 to 4 and we apply the integral for the function. Minus x to the power 3 over 3 plus 2. Here the x is to the power 1. So 2x squared over 2 plus 8x. We simplify 2 with 2 and we substitute the values. Minus 4 cubed over 3 plus 4 squared plus 8 multiplied by 4 minus, now we look at the second value, all the terms have x, so it is equal to 0. Minus 64 over 3 plus 4 squared is 16 plus 32. Minus 64 over 3 plus 48, which is over 1. The common denominator is 3. Minus 64 plus 3 times 48, which is 144. The answer is 80 over 3. This is the area. It also could be represented as 26 and 2 over 3. Look at the description in the book. First of all, we did the sketch of the curve, which helped in this type of questions. Then we defined that R is the area bounded from 0 to 4, and then we multiplied out the brackets. After that, we did the integration and we used the limits of 4 and 0 in order to find the value of the area, which is 26 and 2 over 3. In the same way, you can solve this exercise. The sketch shows part of the curve with an equation that is cubic. Find the area of the shaded region, which is the area here, which is bounded between the curve and x equals minus 2 and x equals 0. You multiply this bracket, then you integrate, and then you substitute the limits. Also, you can solve this exercise. Find the area of the finite region between the curve with the equation y equals 3 minus x multiplied by 1 plus x and the x-axis. This is a quadratic equation just like the one we solved now. Finite regions means that they want the specified area.